Okay, linked genes. These are located near each other. So Mendel said, oh, it doesn't matter, red hair and freckles are on two different genes, so they're inherited separately. That's not always true. Sometimes the genes are very close together, so you do tend to see red hair and very light skin, or you see dark hair and very dark skin, or you see a particular eye color. That means that those genes are very close together on a chromosome, so they are very likely to be inherited together. So the genes that are located near each other on those chromosomes tend to travel together during meiosis, and these genes are often inherited as a set. So Mendel's laws do not always apply to those kinds of things. Many animals, including mammals, also have a pair of X and Y chromosomes. This is inherited differently. We have to do these problems in a little bit different way when I start giving you some genetics problems to work. Individuals with one X chromosome and one Y chromosome are males. XX individuals are females. Human males and females both have 44 autosomes and one set of sex hormones or sex chromosomes. So essentially we have a male and a female, we've got a sperm and an egg, and we get these children. This is how you can have twins that do not look the same. The female has the X chromosome from dad and an X chromosome from mom. The male has an X chromosome from mom and a Y chromosome from dad. So that is how that works. The Y chromosome is smaller, and there's just not a lot of disease or things that are notable on the Y chromosome, except potentially hairy ears. There's a few. We'll talk about them. Basically, when we talk about sex-linked genes, we are typically talking about genes that are found on the X chromosome. So yes, both people have them, but again, you have to look at it differently because men only have one X, women have two X. And these things are red-green color blindness, hemophilia, and muscular dystrophy are all sex-linked recessive alleles. A red-green color blindness is a common sex-linked disorder caused by a malfunction of the light sensitivity in your eyes. Mostly males are affected, but heterozygous males can have some defects. So this is one of those, if you don't see a 7, and you see something else, then you are colorblind. And probably if you're going to be a pilot, we have to have a very hard talk about picking something else. Because they are located on sex chromosomes, you just have to look at these problems a little bit differently. So again, you have to take into account this X chromosome. So these would be the females, these would be the males. In this case, you only have one. This person would have the disease because they only have one copy and they don't have another copy to get, dilute it, if you will. So actually in this case, mom does not have the gene for color blindness, and dad gives you the Y chromosome, so you are not colorblind. However, if mom is heterozygous and has the gene for being colorblind, there is a chance you can be colorblind. If again, mom is a carrier, dad is colorblind, there's even a better chance, even if you're a girl, that you could be colorblind. So these are how those problems work. You have to keep track of the Y chromosome and where it goes. Hemophilia is another example. It's a sex-linked recessive trait with a long, well-documented history. Hemophiliacs bleed excessively when injured because they have inherited an abnormal allele involving blood clotting. So again, people can die from just a small bleed or a small cut. The girls can die when they get their first period. Like basically at puberty, a lot of women died just because they never clotted. And of course, what helped us learn this is the age-old, delightful practice of marriage among royal families and marrying your cousin. So everybody married their cousin, and everybody got hemophilia. So here's an example from the Russian aristocracy, right? So Queen Victoria and Albert married. They had Alice. Alice and Louis married. They had Alexandra. Alexandra married the Tsar of Russia and had Alexis, and that person was colorblind. I mean, not colorblind, that person had hemophilia. So again, we're looking at people who cohabitated with wolves and dogs, and as people moved into settlement populations, they bred their dogs to, in some cases, just be like a wiener dog. Some people bred their dogs to be bigger and you know, for protection, and some people bred their dogs to be like, you know, cuddly and fluffy. So therein lies the delight that is the genetic tinkering of the dog types. So yeah, I'm not. So here we go. We've got, this is a wolf, right? This is a Shar-Pei, which is shockingly close, but it's not really a wolf. And then somewhere along here, I don't even know where the old, like, wiener dog, Yorkie Terrier, some of those delightful purse dogs happened. So that is the end of this section. We just have more pictures of